Hello, welcome. Module 1, Lesson 4, the properties of matter. Okay, first things first, what the heck is matter? Well, anything that takes up space and has a mass is matter. Matter is composed of atoms. So basically, everything you see around us is matter. So all the things we can touch and see, to even the air that's around us. Animals, plants, you name it. Matter. Everything there is made of atom. So you may be asking yourself then, what isn't matter? Well, matter is not energy or abstract thought. So this includes such things as light, heat, or sound, anything that's a wave, emotions, memories, time, gravity, not matter. So we will look at this more in Module 2, but we just wanted to get started with the idea of matter. So every substance is unique in some way, just like a fingerprint is to humans. And if we know enough about a substance, we can figure out what it is. Or conversely, if you know what a substance is, we're able to predict how it will react with other things. So there's properties of matter, and that's what this PowerPoint video is going to focus on today. There's two types of properties we're going to look at. The first being physical, and then we'll look at the chemical after. So physical properties are characteristics of a substance that can be observed without changing it to something else. So here we need to use our five senses to see and touch and smell. It also includes things such as the mass of something or the density, and also the state. Is it solid, liquid, gas? Chemical properties, on the other hand, are the characteristics of a substance that can be determined when it is changed to something else or undergoes a reaction. So, for example, a fire, burning wood, it becomes something else. A rusty chain on a bike, it's no longer nice iron, it's rust, it's become something else. Or fireworks are another great example of a chemical reaction or change. Okay, so let's look a bit more in depth at the physical properties. So again, it's when you need to use those senses, they come in handy for things such as color, luster, opaque, translucent, is the material viscous, what's the texture like, is it flexible, what does it taste, smell like. Physical properties also include the size and shape. So how much do you have? What's the volume, the mass, the length? And it also includes such things, properties as, does it conduct heat? Does it conduct electricity? One that's not written down here, is it magnetic? Those are physical properties. So looking at these 7 pictures, can you predict which items will conduct electricity, which has that physical characteristic? If you said the metal ones and the tap water, you're right. Bravo. Okay, another physical property, hardness. So this is typically measured by resistance to bending, scratching, cutting, or indentation. So one such scale is the Mohs scale of mineral hardness, and we'll often use this scale to relate common objects, as you can see here on the right, with 1 being the lowest of the hardness, talc, it's like a chalk almost, with 10 being the diamond, the strongest natural substance that we know of. Okay, solubility. This is the ability to dissolve water, to dissolve in water. So for example, sugar will dissolve in water, where oil will not. You can see the drops in there. Ductile, the ability to be drawn into long, thin wires. So this copper wire here is ductile because we're able to stretch it out into these long, thin wires. Where this sulfur here, there's no way you could do that. You couldn't heat it up or cool it down. It would just crumble. So this would be non-ductile. Malleable. Malleability is the ability to be hammered or forged into a shape. So is how bendable or flexible is it? So this is perhaps an iron key of some kind, and you can see it's really been forged into a delicate shape. Again, sulfur, you could not get it into that shape of the key. Last but not least, the state of matter. So we've got solid, liquid, gas, or plasma here. We'll talk about this in next module. And an example here, ice, water, steam. So ice is solid. You add a bit of temperature, it becomes water. More temperature, it becomes steam. So the state of matter is a physical property. Okay, now on to the chemical properties. And what you need to note here is the word ability to. So a chemical property is what would happen. What's this substance able to do, or what will it do? So example, the ability to burn or tarnish, ability to rust, decompose, ability to react with other chemicals. So it's what would happen with this chemical. Okay, that's a chemical property. Now we're going to look at changes. So as the word implies, something has been altered or changed. So there's two types of changes. There's, of course, the physical change or the chemical change. Now what your job is to figure out which change is what. And to do that, you need to ask yourself a question. Has it become something new? So if you have a new product, so if you say yes, then you have, you guessed it, a chemical change. If you said no, it's still the same thing, it just looks different, then you just have a physical change. So answer no, we said that was physical. So here are some examples. We got some aluminum foil here, and now it's crumpled. Looks different, still aluminum foil. Glass bottle, broken. Looks different, still green glass. Ice to water, looks different, but you guessed it, it's still just water. This is called a change of state. Ice to liquid, or solid to liquid. Okay. Physical changes are usually reversible. That's kind of another clue or key to keep in mind. Now, if you answered yes, then we've got ourselves a chemical change. Now, before we talk about chemical changes, I'm going to run through some of the signs of chemical changes. So if you have a change in color, remember the fireworks. If heat is released, think the fire. If heat's released, we call it exothermic. Exit, exo. Sometimes chemical reactions can absorb heat, and that's called an endothermic reaction. Enter. If a light is produced, that can be a sign of a chemical change. A precipitate. A precipitate is a word we use for a solid. So if two liquids come together, they'll make a solid. It's called a precipitate. If a gas is produced, note here, without heating. So you just pour two liquids together that weren't bubbling, pour them together and they start to bubble, well then it's a chemical reaction. Or a change in odor, another sign of a chemical reaction. So let's take a look at a couple examples here. So I've got a raw egg and now it's cooked. So chemical change, it looks different. Different color. This is opaque here, or sorry, this is translucent here, and now it's opaque. It smells different. The proteins have actually changed around. It's a new substance. Some bananas here, really green, just ripening up to now it's even starting to kind of decompose a little bit. So they're going to taste different. They're going to smell different. They have different color, different texture. New products are being formed. This is an example of a precipitate. Clear liquid, yellow solid. And last but not least, we got a piece of paper burning. So we have quite a few clues of a chemical reaction. We have a different color here. We see light, we get the heat. We have a whole new substance that's being produced. So all four of these are examples of chemical changes. Chemical changes are not usually reversible. So there's another clue. Now, what I want to do here is I've got four more terms I thought I would just kind of throw out there. Just if you see them once, when you see them again, it'll just be that much easier. So here we go. Properties that we just spoke about can be extensive or intensive. And the clue's right in the word here, ex and in. Extensive properties change with the amount of the substance. So think external. So that thinks, how much does it weigh? What's the mass? What's the length? If you cut something, well, the extensive property changes, right? Or the volume. Intensive do not depend on how much you have. These qualities are internal and never change. So example, smell. Half a banana smells the same as a full banana. Boiling point. Water boils at 100 degrees, whether you have a gallon or a liter, right? If something's going to be reactive, it's going to be reactive on a small scale or a large scale. Intensive. Okay, and then two other terms I'm just going to throw out there. Qualitative or quantitative. Qualitative, think quality. It involves the properties that describe things using descriptions or observations. Qualitative, quality. So these include such things as color, smell, taste, textures. And these are key observations to observe a chemical reaction, because you might notice those bubbles or the color change or an odor, right? So different things like that, the quality of what's going on. Versus quantitative, think quantity, think numbers. That's exactly what it is. They're properties that can be measured. So these include temperature, mass, length, volume, speed, time, sound levels, etc. Okay, that concludes this PowerPoint video. So hopefully you found it informative. Online, there are some more notes that you can read through, add to the notes as you see fit. There's a practice worksheet, so please try that. And for your project or your assignment, there's a lab on physical and chemical properties. Okay, thank you. Have fun.